I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I'll be speaking with Jeff Moredock, who works with Sy-Klone International and the International Standards Organization, to talk about the new ISO 23875 standard that's coming out. Thank you for joining me today, Jeff.
Well, thank you, Sarah. It's a pleasure to be here.
So maybe if you could just start by providing an overview of the new ISO cab air quality standards, sort of, what all it entails, maybe benefits to the heavy equipment industry it provides.
Sure. I would be delighted to do that. ISO 23875 is an air quality standard for operator enclosures. This is currently, and it is a draft standard, meaning that it's not published at this point, so it's not completely finished in terms of the balloting. That will be over on November 10th. We're anticipating that the standard itself should be published, assuming things go well, sometime in January or Q1 of this coming year. This particular standard is designed to protect machine operators from harmful respirable particulates that are found outside of the cab in mining environments. And we do is we apply engineering controls to the cab. We do air quality testing of the cab itself to determine that the air quality in the cab meets the requirements of the standard. This is a very important thing to do because people that are working as operators in environments where there's a lot of silica or asbestos or any one of a number of different respirable particulates, they have a high risk of breathing these things into their lower lung and, as a consequence of that, suffering long-term health detriment. So what we're really focused on here is providing a safe work environment for an operator who's going to spend many, many hours inside of an operator enclosure, and in hopes that that operator enclosure will protect him from the outside environment that he's working in. Received a lot of positive feedback as it relates to people that have seen the standard. We even have some early adopters that are OEMs and aftermarket folks that are already implementing the standard on their workplaces. So far, the stakeholder comments have been extremely favorable around the world, and I'm just really glad we're getting a chance to talk about this today.
So then who all maybe benefits from the standard being introduced? Obviously, I'm guessing the equipment operators for their health and safety, but is it beneficial to manufacturers like Sy-Klone or the equipment manufacturers themselves as well?
One of the problems that we have in the world is in the absence of standardization, you have a lot of things that happen which don't give good results. For example, if I'm an OEM and I'm manufacturing a drill and I want to export that drill to Australia, in order for that drill to be used in Australia, it has to comply with certain regulations that affect air quality in that cab down in Australia. And the consequence is, first of all, I have to understand what that particular regulation would be where I'm sending it, in this case, Australia. But then I'd have to figure out how to engineer my cab to meet those requirements. Now, assuming that the market in Australia was large enough and I wanted to do that, I could certainly do that. But the problem with it is, what happens when I want to send that same drill to Canada or to Europe or to Malaysia or to some other country? And then they have a completely different approach to how they're going to want that cab set up. So the international mining community got together through ISO and said, this is restrictive to trade. We're not able to build 15 different cabs. We want to build one. We want to get the economies of production on building one, which makes it low cost to do as opposed to the very expensive 15 cab choices that we'd have to build if we wanted to go into all these different regulatory environments and comply. They came together and said, this is the problem that we want to solve. I was tapped to be the international project lead for this, and our goal throughout the entire project has been to reach out to all the stakeholders in the world, that is the end users, the operators, the industrial hygiene community, which is going to be looking at the health impacts of this as these cabs are used in the field, then the OEM, who is saying, we'd like to solve a trade problem. We'd like to be able to sell our machines around the world without having to go through the drill of figuring out what all of the requirements are and then making all these engineering changes, which ultimately don't get done. And that creates even a bigger problem for the end user who gets a machine that may not comply with the requirements locally, and then they have to spend a lot of money to make that machine comply in that market after the machine's already been built at the factory. So there's a lot of people who are involved in this process that have a lot to gain. In fact, everybody has a lot to gain in this process. Obviously, we want to encourage international trade. Our OEMs want to make a profit. They want to do things in the most economical way. They want to give a high quality product and a product that will protect the operator. And the way you do that is through standardization. We've stepped back and we've said, what are the engineering control requirements and what are the performance tests that we would need to perform at the point of manufacture or at the point of retrofit to ensure that that machine is going to, in practice, protect the operator from these harmful respirable particulates. We call together subject matter experts from around the world. We have 10 countries that are involved in this effort. We have OEMs like Caterpillar and Komatsu and Volvo and Epiroc, J.H. Fletcher, some others. We have industrial hygienists representing the largest mining companies in the world on the committee. We've got consultants to the mining industry. We've got kind of a whole bunch of different stakeholders. When we were done, we had 22 subject matter experts, and then we had additional people that were just good at writing standards. So of those 22 people representing those 10 countries, we all put our heads together and thought about the manufacturing problems. What is it? And that's what I'm relaying to you now. These are the things that they're very concerned about. In the end, it's about how do we get safety, that is, how do we improve the operating conditions and provide a safe environment for the person that, quite frankly, doesn't even have a seat at this table. We don't have an operator at this table. We have everyone else, but the operator is not there. But all of this is ultimately being done for the operator to be able to go home at the end of the day with a clear set of lungs. So it has a very altruistic benefit as far as the operator is concerned. But the economics are what makes it work. If we can get standardization around this topic and we can start building cabs the same way, and we know when we buy a cab that's built under the standard that it's going to perform at an acceptable level for my local regulator, for my health and safety department, then we will have achieved just a tremendous economic boon for those people who have to do this today in the world and, quite frankly, who are paying a steep price because of the way that we've been doing it up to this point.
So then what will be required of equipment manufacturers and cab air system suppliers to meet the new standard?
That is a great question. And I have to say that that's a really critical question as it relates to, what changes are coming our way as a consequence of this. And there are several things that we're focused on in the standard. One of them is understanding the effects of filtration, how filters are used to pull the particulate out of the air. And as we looked at that and looked at the level of filtration that's necessary, you realize that the particulate that is most damaging to the lung, you can't see it. It's way smaller than anything that you can see. It really is true. What you can't see will kill you. And so when you look at filters that can pull these particles out of the air, that became a really, really important part of the standard. So as we look through the different options for filter testing methods, for filter manufacturing, we settled on ISO 29463, which is another ISO standard for filter testing and manufacturing. And it is a fantastic standard for development of human respiratory filtration, filters for our needs, for protecting operators. We have adopted that. So that's one significant change. I mean, these are filters that are significantly more efficient than the filters that have been traditionally used. The consequence of that, of course, is that many of the filters, many of the applications for filters are going to have to be re-engineered or rethought through regarding the level of restriction these filters provide as opposed to less restrictive, less efficient filters. So there's some engineering issues associated with that. All of those are good. It's driving us towards better manufacturing, better understanding of how filters work. And quite frankly, in the end, we're going to have a lot better filter program across the world as a result of the effort. The second thing that's really important is understanding that when you have an operator in an operator enclosure and he's breathing, he's drawing oxygen out of the air and he's replacing that oxygen with CO2. That's a problem because if you don't have adequate oxygen in the cab, lack of oxygen causes you to, it impairs your mental processes. So you may make bad decisions when you're operating the cab. If you're operating a boom and a slight movement in the joystick could cause something very heavy to hit something or somebody on the ground, there's huge safety concerns about anything that would impair the mental acuity of the guy that's sitting in that cab. So we want to be very careful to understand what is an acceptable level of CO2. Or the flip side of that is, what is an acceptable level of O2, oxygen, in the cab? So what we've done is we're measuring the amount of CO2 in the cab, which is telling us how much oxygen is in the cab. It's kind of the reverse, right? If you're taking all the oxygen out, what you have is CO2. So if we measure the CO2, we can tell you how much oxygen is in the cab. We're able to measure the CO2 very accurately using some new technologies that are out. There are required in the standards. So this is requiring that the monitoring devices, that we will have monitoring devices mounted in the cab permanently, that they will be monitoring in real time the CO2 levels inside the cab, and that those CO2 levels will be attached to an alarm system, so that if the CO2 rises to an unsafe level, there will be an alarm that sounds to let the operator know that he needs to change whatever he's done to cause it to get to that point. And that's a significant aspect of the standard, is looking at CO2 in the cab and understanding that we have to have a fresh air coming into the cab to dilute the CO2 that's there. We need a continuous supply of that. And how all that's done is a very interesting aspect of the standard. The next thing is that we're focusing on how effective the recirculation system is inside the cab. So when you get in your car, you have a button that says, full recirc or recirc mode, and your fan kicks up to high, and you hear a lot of noise, and all the air is recirculating, and you're pulling it through a filter inside of the cab. Well, the same thing's true in an operator enclosure on a piece of heavy equipment. There's a recirculation system, and there's a filter inside the cabin. And so what happens when the operator is operating in a dusty environment, and he gets in the cab, and when he gets in, he brings in with him a bunch of dust. What happens to that dust? So we're looking at that. We're saying, okay, let's measure that. Let's determine how quickly that cab strips those particles out of the air and restores the air quality to the pristine state that we'd like it to stay in while the operator's in there working. So that's another aspect, is the recirculation filtration as well as the fresh air filtration. So we're looking at all the filters and how effective they are in stripping the particles out of the air. Last thing is this monitoring system. One aspect of the cab that's very important is maintaining pressure inside the cab that's greater than the exterior pressure. And that means that the airflow, that when air is brought into the cab, it's being pushed out through the cracks in the cab, and it's leaving all the time. That's taking the CO2 out, it's taking particulate out, and it's keeping the dust from outside of the cab from coming in through those same cracks. So if the air is only going one way, the dust can't come back in through those cracks. So cab pressurization is very important, and that's another aspect of the performance of the cab that we require. And the monitoring system that we have incorporated into the standard is looking at cab pressurization, and it's looking at CO2, and it is allowing, it's setting off an alarm if we have the parameters that are guiding CO2 and pressure, if they're exceeded. So in real time, the operator will know if his air quality has been compromised. So that's how that works. Now, the other thing about the standard is that many standards from an engineering perspective address just engineering issues at the point of manufacture. This standard, because the stakeholders are, the engineer at the OEM who's designed the cab, who's going to design it, and then we're going to performance test it at manufacturing. Then the cab is going to be turned over to a buyer, a mining company, and when they receive the cab, they're going to get a set of maintenance instructions and a certification of compliance with the standard, and they're going to turn it over to their maintenance department, who's going to put that into their maintenance program. And so the question is, what happens from then on? I mean, it's okay if we get it right at manufacture, but what about 8 months from now, or a year from now, or 2 years from now? This standard starts at the design or at the retrofit, and it goes all the way through until the machine is ultimately retired out of business. It's buried in the ground, from that entire process. So this maintenance, we call it a life cycle standard. So responsibility for maintaining that cab transfers from good design and evidence that it passes by a performance test into a maintenance manual, which is then religiously adhered to in maintaining that machine throughout the life cycle. And then the same testing that was done back at the factory can be done by the maintenance person, it can be done by the industrial hygienist, it can be done by anybody downstream to validate that the maintenance protocols are giving you the same level of performance that you bought when you bought the machine originally. Liability transfers from the OEM down to the user of the machine, and they're responsible for it from then on. The standard it's very transparent about who's responsible for what. And in the end, it becomes the responsibility of the machine owner to make sure that it's properly maintained under the maintenance protocols that are given to them by the manufacturer in their maintenance manual.
So then how will a manufacturer, machine owners know that they're meeting the standard or the requirements? Is it that monitoring system, or can you maybe go into a little more detail on that, if at all possible?
In the design process, there are specific engineering controls. For example, a type of filter, a classification of a filter that are called out in the standard. One of the things that is part of that engineering control process is the monitoring. You're going to design the cab with good seals. You're going to design it with a pressurization system, with an air conditioning system, and all these things. And that's great. But if you don't have a way to evaluate that all those things are actually working and working together to give you an end result that is predetermined by a standard, whatever that would be, then you don't know if it's working or not. So what the standard lays out are all of those things, all the engineering control requirements. And then it says, when you're done building this cab, now we're going to test it. We're going to test the pressure. We're going to test how well it does when you bring dust in the cab and getting rid of that dust. We're going to see if there's any leakage in the HVAC system, which could bring dust into the cab and bypass the filter and thereby contaminating the operator. We're going to make sure that the cab is sealed correctly by doing a pressure test at the end. Then we're going to put the operator in the cab, and we're going to see what happens to the CO2, if the CO2 goes up or if the cab's able to bring in enough fresh air to keep the CO2 underneath the threshold so that the alarm doesn't go off. And all of those things are the ways that the OEM knows that he has met the requirements of the standard. In the end, when those performance tests are done and the maintenance manual, which is discussed at some length in the standard, is completed, he will then do a self-certification of compliance with the standard. We call it a certificate of conformity. And when he passes that machine over to the buyer of the machine, the buyer of the machine gets a machine that's been designed correctly, it's been performance tested, and they provided a certificate of conformance that says we've met the requirements of ISO 2375, and the OEM has finished his mission. He's turned it over to the customer. There are some interesting things here that accrue to the benefit of the OEM that are really worth talking about. In the world of mining, the way that mining inspectors enforce good practice inside of a mine site, at least I'll speak to the United States here. We have the Mine Safety Health Administration, or MSHA. MSHA regulates the mining industry. And when an MSHA inspector comes in and he takes a look at a machine, he will get out the maintenance manual for that machine. And he will look to see what the factory said was required under the maintenance for maintenance of that machine. And he will compare that to what's actually been done on the machine. If he sees that there's a discrepancy, then he can fine the mine site for lack of compliance. Well, the wonderful thing about this standard is that after you know that the machine works, you've got the engineering controls right, you've got the performance testing demonstrating that you've got a good design and it's working properly. You write your manual and you say in the manual that these are the parts that you are going to use for replacement parts. So if you've certified that machine using a specific filter from your company and you write in there that the part number that you're going to replace that filter with is this part number, that's the part number that they're going to buy. Because if they don't, and the MSHA inspector comes out and he looks at the book and he says, you're supposed to have an ISO 35H filter in here, and I don't have any filter labeling at all on this filter. It's obviously not the filter that the OEM certified under, then you're going to be fined for it. Whatever the OEM says in that manual becomes the way it's going to be enforced in the MSHA world. And that's a very powerful tool. It also gives an opportunity for the OEM to include the cab in the certification process under the warranty for the machine. To say our warranty extends to this cab into the certification as long as you maintain the cab, under the requirements that we've set out in our maintenance instructions. And that also is a very powerful way that the OEM will accrue the service parts business over time and ensure that their machine is treated fairly, that it's working correctly and it's properly maintained.
And so you were mentioning before that there are some new technologies that will need to be developed and implemented in order to help meet the standard. Are you able to go into some of those and what they are, how they will help meet the standard?
Well, that's a super point, Sarah. Thank you for bringing that up. I think that the thing that has been most impressive about working with this international group is that it's been very forward thinking in terms of how we can improve, but understanding that sometimes it is a stretch. And one example of that is the filter efficiency, and getting to that level of filtration efficiency. It's going to require new technologies. There's already been new technologies that have come out to try to address this problem. So I think it's very constructive. I would make one observation that the types of filters that we're talking about, like an ISO 35H filter, is highly effective against the coronavirus. Mm-hmm. So if you're in a cab and you're exhaling coronavirus and it's hitting that filter, it's not going past the filter. It's getting stopped in the filter. And that's really unusual for that level of that high efficiency filtration to be out there today and to be able to be implemented in a way like we're talking inside of an operator enclosure. So that would be an example of technology advancement that's really helping us. It's not just the coronavirus, it's any virus, so it's really helpful just in communicating disease from one operator to the next. The next guy in the cab, isn't going to be breathing the same thing that the previous guy was breathing. It got taken out in the filter. So that's an interesting health benefit. But there's other things. Recently, Niosh put out a contract for a smart cab electronic system that they're trying to have developed. Interestingly enough, inside of 23875, we deal with current monitoring requirements, which we've discussed. But then we also have a bunch of recommended monitoring ideas. And it was put in there specifically to stimulate industry to kind of get on the ball. Let's take what we know we can do and let's do it. And so the consequence of that is, one thing that's come out of that is this Niosh Project. And the Niosh Project seeks to figure out how we can automate as many of the functions of the cab as we can, both in the monitoring and then actively resolving problems. If, for example, the CO2 goes up, it automatically allows more fresh air in the cab. The operator doesn't have to do anything. And the idea is that the cab, like your car, when you put it in automatic mode and it is constantly changing and keeping you comfortable, it's the same thing in the cab. It's just dealing with it with a dust dynamic and a CO2 dynamic, which is also present in automobiles for that matter. But we are looking comprehensively through this technology on how to protect the operator. So that's a pretty exciting thing that's coming up. The other thing that's happened, which is really important in the mining industry, because we deal here with a lot of dust. Mm-hmm. And dust has been the perennial problem. It's not just breathing it, it's putting a filter in the way of it. When I put a filter in the way of a lot of dust, the dust clogs the filter and air doesn't flow through the filter anymore. And to the extent that that happens very fast, the filter stops working very quickly. And if I'm out in the middle of if I'm 1,700 feet under the ground and I'm not near a maintenance department and my filter goes down, I'm operating without good air quality in my cab until that can be fixed. So one of the technologies that has come out is the ability to strip those particles out of the air at a very, very high percentage, at a very small micron size with no filter at all. And what that's allowed for is really a significant advancement in our ability to field high efficiency filters like we're talking about in the standard, and putting them into really tough mining environments and having them survive throughout their planned maintenance interval, which could be 500 hours, 750 hours, 1,000 hours, without having to change that high efficiency filter. Quite frankly, without that technology, we wouldn't be talking about a lot of this today, because that really was an empowerment to introduce high efficiency filtration and these other things that we're talking about. That was kind of a building block item in the technology revolution that's brought us to where we are today. There's lots of opportunity here in terms of technology development, and we're very excited to see what all is going to come as a consequence of what this standard is asking for in terms of operator enclosure performance.
And so you were mentioning it's applicable for the mining industry. Is it just the mining industry that the standard is applicable for, or does it apply to other heavy-duty applications like construction, or could it be applied to those, or would those require other different standards?
The ideas around this standard did not come from mining, particularly. They came on how to design a properly functioning operator enclosure that addressed all of the things that we're talking about. Mm-hmm. The fact that it was adopted by mining tells you that they had a sense of urgency that was greater than other industries in this area. We started researching years and years and years ago with the National Institute of Occupational Safety and Health. And through that period of time, something very important happened in the United States. We've had a problem for years. I'll say millennia, but we've had problems in this country since the founding with silica. When you're cutting rock, quarrying rock, the fine aerosolized quartz particles that come off that rock get in your lung and they give you silicosis. It's extremely severe disease, and it's terrible, and it can take you out at a very young age after not much exposure in terms of time. So that problem was addressed by the United States government, and Niosh was responsible for doing workplace research to try to figure out how do we address this problem in real time. So we got involved in 2003 with Niosh, trying to answer that question candidly. What came out of that ultimately was adopted by OSHA, and in 2016, OSHA released the silica rule. And this document, some 1,750 plus pages long, addresses, amongst other things, operator enclosures and how we protect operators and operator enclosure. When that standard or when that regulation came out at that time, there was not a standard that OSHA could point to and say, hey, if we just use this standard, that would take care of the operator enclosure piece of our silica rule. Mm-hmm. Instead, they got recommendations from a lot of people, including Niosh, on a variety of things, and they put together, affectionately known as the CAB piece of Table 1 of the standard or of the rule. The problem with that is that when it comes to enforcing it, it's not put together in such a way that it's really that enforceable. It's difficult to understand. If you're a judge and you read it, you say, I don't understand this. Well, if the judge doesn't understand it, it's really hard to get any kind of enforcement around that. So that has been a really, really big problem for OSHA. OSHA wants to reduce the amount of silica deaths in this country, wants to reduce the amount of silica exposures that are taking place in this country. So I sat down with OSHA, presented this to OSHA back in August of 2019 up in Washington, D.C., and we had the conversation around what this standard was all about, and I could tell that as when we were going through it, that they were getting very excited about what they were hearing. And at the end, I said, well, would you consider using this standard in the OSHA silica rule? The reason that was important is because they've now opened up the silica rule and asked for revisions. So now would be a time to be able to change the silica rule and adopt something like this. The answer that I got back, frankly, shocked me. They said, yeah. I mean, when we were chartered, they said when we were chartered by Congress back in the 60s, they said as a part of our charter, it says that we are to use consensus standards when a consensus standard is available. At the time they did the silica rule, there was not a consensus standard that they could use. When this becomes a published standard, they now have an industry-accepted, industry-developed standard that they can now use to regulate the way they're going to address cabs moving forward. Still a huge amount of interest. So this kind of gets right to the heart of your question. OSHA does not regulate mining. OSHA regulates everything outside of mining except for agriculture. Okay. So they have a much wider net in context of machines built and cabs used and all those things. I would suggest to you that the standard is as useful and as effective on any kind of cab or enclosure. It doesn't have to be on a machine. It can be an operator station in an industrial facility. It can be a crusher booth, at an industry, at a processing facility. It could be anything where you've got an environmental control of the air quality. And so it was definitely done for mining. There's no question about that. We're sponsored by Technical Committee 82 Mining. But the reality is that what it proposes can be used equally on any kind of operating equipment that has an enclosure on it. So hopefully that answers the question. It could be agriculture, it could be construction, demolition, stevedoring, whatever. It really doesn't matter.
How, if at all, does the development of this new standard fit in with any current industry trends for cab air quality systems in the heavy equipment industry you guys might be seeing?
Right. So, wow, there has been so much that has changed in this space in the last, I'd say 10 years, but I would accelerate to say it has really accelerated. When the OSHA silica rule came out on the U.S. regulatory level, at an OSHA level, and actually was addressing specific things in the cab, that was a huge change in the way that people looked at this area. It's been known for a long time that operator enclosures aren't always the healthiest places in the world to be for a host of reasons, but there has been a real awakening or awareness that has come about. And it's not just in the United States by any stretch. It's every country. This is actually why the standard exists. If there were no air quality regulations, if the industry wasn't trending, I'll put it this way, if the regulators weren't trending towards improving human health as it relates to air quality and operator enclosures, then we wouldn't even have the standard because there would be no need for it. They build a cab and they send it anywhere in the world and it would just be accepted for whatever it was. But because of all of the regulations that are driving air quality, this standard suddenly became really important for trade, as we discussed earlier. And so that's really prima facie evidence is the fact that the standard exists. If there wasn't a need for it, if the industry wasn't trending that way, listen, there's millions of standards that don't exist today because nobody's asked for them yet.
Well, those are all the questions I have. I really appreciate you taking the time to speak with me today and talk about the new standard and how it will affect the industry.
Well, I'm super glad to do it, Sarah. I would point out that for anybody that has additional interest in this, you can go to iso.org or you can type in ISO 23875 and you'll find it right there at the front of your Google search. It is a purchased standard, as all ISO, that's how they fund ISO. If you go on there, you can buy the DIS version currently. In a little while, you'll be able to go on there and purchase the final published standard. And we look forward to getting as much industry participation and support as we possibly can. And thank you so much for spending time today to investigate this, Sarah.
Yeah, definitely.